Okay, so let's look at the second method of solving systems of equations. It's called the substitution method. Now, this one has some steps to go along with it, and as we work through these steps, we're going to work out this problem at the same time. Remember, our goal is to actually solve for an x and a y, a number for x and a number for y that will work in both these equations. Are you with me? For graphing, what happened is we had to look for an intersection, and that was the x and the y that worked. In substitution, it's a little bit different. So let's look at the first step and then take it from there. So first step says solve one of the equations for one of the variables. Now, it didn't tell you which equation to work with, and it didn't tell you which variable to solve for. So let's take a look. I have an x and a y in the first equation, and I have an x and a y in the second equation. Now the question is, which equation should I work with, and which variable would be the easiest to get by itself? What do you think? Okay, so I'm going to go in the first equation, and I'm going to solve for x. I'm going to get the x by itself. Any idea why? Well, here's what I'm noticing. In the second equation, if I want to get that x by itself, eventually I have to divide everything by a -3. Agreed? But not everything in the second equation will divide evenly by -3, which means I'll end up with fractions. Yeah, don't want to do that. In equation 2, the same with that y. If I want to solve for that y, eventually I have to divide by a -8. Well, not everything's going to divide nicely by -8 in the second equation. So that's why I didn't even go with the second equation. Cool? Okay, so in the first equation, why did I not want to solve for y? Right, because I'd have to divide everything by a -4, and not everything will divide nicely by a -4. So, in the first equation, I am going to solve for x. I am going to get the x by itself, because it has a coefficient of 1, which means all I got to do is move over the 4y, and we're good. So, -5, or x equals -5 plus 4y. Cool? Okay, and there are some of you are like, wait, can't I write it the other way around, 4y minus 5? That's fine, whichever, it's the same thing, right? Okay, step 1, done. And by the way, sometimes they do step 1 for you. Sometimes they actually give you an equation where the variable is already by itself, so yay for that. Okay, let's look at step 2. In the equation you did not use yet, substitute the expression from step 1. Okay, so let's go with the first part. In the equation you did not use yet. So which equation did I not use yet? Yeah, I didn't use the second equation yet, did I? I haven't used the -3x minus 8y equals 0 yet, have I? So it's saying, in this equation you did not use yet, substitute the expression you got from step 1. Well, isn't this the expression I got from step 1? So that expression says x equals, right? Now remember what the equal to sign means. Whether it looks like it or not, the left and the right side are exactly the same. Are you with me? Whether it looks like it or not, the left and the right side are exactly the same. That's what the equal to sign means. So, in this expression, I have -3 times x. Well, do I know x? Yeah, actually I do, because in the first step, we told ourselves x equals 4y minus 5. So I'm going to take out the x, and I'm going to replace it. I'm going to substitute in place of x 4y minus 5. And then minus 8y equals 0. Cool? Does that make sense? Okay, hang in there. I'll be right back with the other step. So, we left off with this equation, right? Now, by the way, this is the heart of the substitution method. Notice I now have one equation all in the same variable. In this case, it's all in the variable y, which means technically I can solve. And I can solve for what? Yes, I can solve for y. So instinct tells us to solve anyway. Well, that is step 3. We're going to solve. And so we do our distribution first, right? Because multiplication comes before subtraction, right? And then collect the y's together. Do you agree? Okay. So that looks like a negative 20y plus 15 equals 0. Yes? And then, good, move the 15 to the other side so I can get the y by itself. And then divide by negative 20. Okay, I'm seeing a fraction. Well, so be it. If my answer is a fraction, my answer is a fraction. First and foremost, negative divided by negative is positive. And reduce 15 over 20 by what number? Good, by 5. So that makes it 3 over 4, doesn't it? So, well, we found that y is equal to 3 over 4, didn't we? Great. But are we done? Yeah, no, because we didn't just have a y in the original equations, we also had an x, didn't we? Which means we don't just solve for the one variable, we solve for the other variable, which is the fourth step to do. So, solve for the other variable. Now, I rewrote the original two equations, and we had rearranged the first equation into x equals 4y minus 5. Agreed? I know what y is, and now I've got to find x, don't I? Well, here's the great thing. I can use one of the two original equations, or I could use this rearrangement, because don't I already know y? And if I plug it in here, wouldn't I find x? Yes, of course I would, right? So we would have x equaling 4 times 3 over 4 minus 5, right? Okay, what happens here? Yeah, the 4's drop, don't they? So I end up with 3 minus 5, which means, yep, x equals negative 2. So we end up with the ordered pair negative 2, comma, 3 over 4. Now, here's what I want you to realize. I actually have a solution, don't I? Which means if I took these two linear equations and I graphed them, what does this answer mean? If I took these equations and I literally graphed them, what does that answer mean? Yes, some of you said it. That would mean that this point is the point of intersection. That's what that means. This point would be where these two lines would actually intersect each other. Now, when you're graphing, it's kind of challenging to see a fraction as an answer, which is why graphing isn't always a good method or the best method to use. It's a good method because it visually shows me what's happening, but it's not the best method to use when I'm going to have an answer that's a fraction. Cool? Okay, so by the way, this is going to be what kind of system, since I actually have a point of intersection? Good. This is a consistent system. With me? All right. How are we doing? Does this make sense? Okay, one last step. Step 5 is the check step. You're going to take your solution and you're going to plug it into both equations to make sure that it works. So if I look at the first equation, I'm supposed to write x, which is negative 2 minus 4 times y, which is 3 over 4, right, equals negative 5. Well, the 4's drop, don't they? So I end up with negative 2 minus 3 equals negative 5. Does that check? Check. That one works. But I got to make sure it works in the other one too. So we have negative 3 times x, well, x is negative 2, minus 8 times y, well, that's 3 over 4, right, equals 0. So this will be a positive 6, won't it? Okay, so when I multiply these two ways you can do it. 4 goes into here twice, so I'd have a minus 6, wouldn't I? Or, if you multiply these together, you would get 24 over 4, which is still 6, isn't it? So one way or another, you're going to get a negative 6 here, or I should say minus 6. And 6 minus 6 is certainly 0. Check! If I take the 5 seconds or even 10 seconds to check the answer, and the answer works in both these equations, then I know I have 100% on this problem. So I know this answer is correct without a shadow of a doubt. Cool? Okay, hang in there. Got another one for us. Okay, so we're still solving using the substitution method. So let's look at number 2. Hopefully you wrote down the steps as I was going through it in the last problem. Did you? If you didn't, rewind this video and go write those steps down because I'm assuming you did. Okay, so first steps first. Remember what the first step is for the substitution method. Good. Solve one of the equations for one of the variables. Well, in this case, problem number 2, equation number 1's already solved for x, isn't it? So do I have any solving to do? Do I have any rearranging to do? No, I don't. So we're good. Step 1, taken care of. Remember, I said sometimes they do that for us. Step 2, we need to look at the equation that was not used yet. So which equation was not used yet? Yeah, this equation was not used yet. And so we need to substitute, replace the expression we just got, which is this one, into this equation we did not use yet. So the equation we did not use yet reads 3 times x. Well, from the first step, this is the x I'm using, isn't it? X is equivalent to negative 3y plus 4. With me? And then plus the 9y equal 12. Right? Okay, so remember, this was step 1. It was already done for us. This is the step 2. We're replacing, which we did. Step 3 is to solve, isn't it? And I can, because I have this equation all in the same variable. With me? Okay, so step 3 is to solve. So we get negative 9y plus 12, because we have to do the distribution first, right? And then on the left side, I'm going to collect all the like terms. Agreed? Uh-oh. I'm seeing the minus 9y, minus 9y and a positive 9y. I'm seeing that's going to drop out. So on the left side, I just get 12. Uh-oh. So we wiped out all the variables. Now what do we do? Well, if they want to go, let them go. If they don't want to hang around, I don't want them hanging around either. Got it? So let me ask you a question. Does 12 equal 12? Yeah. Does 12 always equal 12? Yes. So here's how you interpret this. Because I ended up with a true statement, if I actually graphed these two equations, they would be the same line. This, all the variables dropping out and us being left with the number equal to itself, tells me that when I graph those two equations, they're the exact same line. So then how many solutions do I have? Yes, because of this statement being true, I have an infinite number of solutions. Do you remember what kind of system this is? Good, I heard you. This is a dependent system. Now, when we were graphing, I showed you one way that you could write the solution. I showed you as an ordered pair, right? The x with the y. Here's another way that we could write the solution. So don't write, I need you to just watch what I'm going to write. We have the set of xy, because it's a set of points, right? Such that. That's what that line means, is such that. So remember, this is set notation because those little braces are read as the set. So we have the set of xy such that, now remember what we said, these are the exact same line, aren't they? Well, the first equation looks like the reduced form. Because if I take equation number 2 and divide everything by 3, right, I could still do that. That's not reduced. So this is the reduced form, isn't it? So the set of x, y, such that x equals negative 3y plus 4. With me? Or the set of the points xy such that if I take this 3y and add it over, we would get, sorry, got to write the x first. X plus 3y equals 4. Okay? So just so you know, both the same thing, except this one has the x's and y's on the same side, which most authors prefer this way, but I'm just letting you know. Cool? Okay. Got that one? Let's look at number 3. Okay, so what's the first step? I'm using substitution. Solve one of the equations for one of the variables. All right, so which equation do we want to use? Good, second equation, I agree with that. Which variable? Yeah, I'd use the y also. Good, I'd solve for that y also because it's already basically by itself, isn't it? All right, so what do you have to do to get that y by itself? Good, you're going to have to minus the 2x over. So we'll get y equals negative 1 minus 2x. Agreed? Okay, so that's the first step. Now what? Substitute into the equation you did not use yet. So which equation did I not use yet? So here's step 2. Yeah, I didn't use the 4x plus 2 times y. But don't I know why? Yeah. Y is equal to negative 1 minus 2x. Right? Okay. Equals 5. Cool? Okay. This is what we want, right? This is the goal of substitution. I have one equation all in the same variable, which now my brain says solve, which was that third step. So 4x, looks like I have to distribute, minus 2 minus 4x equals 5. And now collect some like terms, right? Oh, looks like those x's are dropping out. Well, if they want to go, I'm letting them go. I don't want them hanging around if they don't want to hang around. Oh, but I get negative 2 equals 5. Does negative 2 equal 5? No, that's not true. That's a false statement. All right. Since that's a false statement, these two lines, if I literally graph these two equations, and this isn't true, and I can't solve for x or y because they're gone, this isn't true. Do you have an idea what kind of lines these would be? I think some of you may have said it. Say it again. Yeah, these two lines would be considered parallel lines because they're not intersecting. Got it? They're not crossing each other. They're not touching each other. I have a false statement here. That means there's no way that I am going to get an x and a y that work in both those equations. So, what solution? Yeah, there's no solution here. Do you remember what kind of system this is? Excellent. This is inconsistent. Good job. This is an inconsistent system. Cool? Okay, hang in there. Got one more, method for